Look up. On a clear night, away from the city lights, the sky puts on a show. A river of stars spills across the darkness. We call it the Milky Way, our home galaxy. For as long as we have been human, we have stared into that glittering abyss. The night sky calls to something deep within us, sparking a sense of wonder. This cosmic curiosity is woven into our DNA. These were our first attempts to make sense of the universe, to find our place in it. That ancient wonder has only grown stronger with knowledge. Are any of those planets like Earth? Are we alone in this vast cosmic ocean? The dream of reaching for the stars is one of humanity's oldest and most powerful dreams, and in the last century, we took our first steps off our world. For most of human history, Earth was the entire universe. It felt immense. In 1990, Voyager 1 turned its camera around for one last look. From that distance, it took a picture of our home. Earth is just a tiny speck of light, a single pixel suspended in a sunbeam. The astronomer Carl Sagan called it a pale blue dot. It showed us just how small and fragile our world really is. On this tiny dot, every person you have ever known has lived out their lives. Happened right there. On a mote of dust floating in the vastness of space. Seeing our world this way gives us a sense of humility and responsibility. This is our only home. We are all passengers on this small, blue world. They saw a world without borders. They allowed us to see ourselves from the outside, to understand our place not just on Earth, but in the solar system. And so, we began to explore our neighborhood. Each mission has been a chapter in our family history. The pale blue dot is just the starting point. The real challenge lies beyond the fence. Our solar system feels enormous, and it is. The true edge is the Oort cloud, a giant shell of icy comets. Scientists believe it extends more than a light year from the sun. This is the Great Wall of Space, a barrier of pure distance. Even at top speed, reaching Proxima Centauri, our closest neighbor, would take thousands of years. The emptiness between stars is the biggest challenge we face. Leaving the solar system requires a leap of a completely different magnitude. The journey to another star dwarfs everything humanity has ever attempted. How do you cross an ocean that is trillions of kilometers wide? Not with the tools we have today. Our rockets are magnificent machines. They are powerful enough to break free from Earth's gravity. They have carried us to the moon and sent our probes to every planet in our solar system, but they are fundamentally chemical rockets. They work by burning fuel to create a controlled explosion. This pushes them forward. It's a great technology for short trips, but for interstellar travel, it's like trying to power a transatlantic voyage with firecrackers. You would need more fuel than the mass of the entire universe to get anywhere meaningful. So the dream of leaving the solar system is really a dream of starships. Not just bigger rockets, but entirely new kinds of machines. Vessels powered by principles that we are only just beginning to understand. This is where science fact meets science fiction. We imagine ships driven by the power of the atom. Nuclear fission or fusion could provide continuous thrust for decades. We dream of vast, shimmering solar sails. Giant mirrors pushed through space by the gentle but relentless pressure of sunlight itself. Or maybe even more exotic ideas like scooping up interstellar hydrogen to fuel a fusion engine as you go. These are not just wild fantasies, they are serious concepts being explored by physicists and engineers. Each one comes with its own colossal challenges. A fusion-powered ship would need to contain a star in a magnetic bottle. A solar sail would need to be kilometers wide but thinner than plastic wrap. An antimatter drive, the most powerful of all, would require us to produce and store the most volatile substance known to exist. Building any of these would be the most complex engineering project in human history. It would require breakthroughs in materials, science, energy production, and robotics, but the dream persists. Because it is about more than just technology, it is about the future of our species. We know that stars are not eternal. Our own sun will one day swell into a red giant, engulfing the Earth. Life on this planet has a deadline. Long before that happens, other cosmic dangers could threaten our existence. An asteroid impact, a nearby supernova, spreading out to other star systems may be our only long-term survival strategy. The dream of starships is the dream of becoming a multi-planetary and then a multi-stellar species. It is a dream of securing a future for humanity among the stars. Our journey began not with a giant leap, but with a series of small metallic steps. Before we could send humans, we sent our proxies. We built robots. Hardy, brilliant explorers designed to withstand the harsh realities of space. These were our eyes, our ears, and our hands in worlds too distant and dangerous for us to visit in person. They were our pioneers. The first generation of space exploration was an age of machines. They carried our curiosity on circuits and our ambition in their antennas. Each one was a marvel of engineering, a testament to human ingenuity sent out into the great unknown on our behalf. The Soviet Union's Luna program was one of the first to taste success. In 1959, Luna 2 became the first human-made object to touch another celestial body when it impacted the Moon. Just a few weeks later, Luna 3 flew around the Moon's far side. It sent back the first grainy, ghostly images of a face no human had ever seen before. This was a revelation. It showed us that exploration was possible, that we could reach out and touch the cosmos. The Americans followed with the Mariner and Pioneer programs, sending probes flying past Venus and Mars, giving us our first close-up portraits of our planetary neighbors. These early missions were audacious gambles. We were learning as we went. Rocket science was new. Communication over millions of kilometers was a staggering challenge. Many missions failed. They exploded on the launch pad, veered off course, or simply fell silent, lost forever in the void. But with each failure, we learned something vital. With each success, our picture of the solar system grew sharper. We discovered that Venus was a hellish greenhouse, its surface hot enough to melt lead. We saw that Mars was a cratered, dusty desert with polar ice caps, a world that felt tantalizingly familiar. These robotic pioneers paved the way for everything that followed. They were the scouts sent ahead to map the territory. They measured radiation, analyzed atmospheres, and photographed surfaces. They told us where it was safe to go and what dangers to expect.